Okay, so now we're going through this one. Let's see what it says. Worked example 2, is it? So we have this grouped frequency table. They say the grouped frequency table shows the weights to the nearest gram of the iPhone 23 cell phone covers that are sold in Cell Phone Tribe. Okay, right, great. So now they're saying draw a histogram to illustrate the data and state the model class. Now, what do? We are supposed to draw a histogram? Yes. So we go ahead and we make our second table. You know we need it. So before we think about anything, we're going to go ahead. We'll say weight in grams. And then the next thing is we need the boundaries, because that is the reason why we are making the table in the first place. Okay? We are going to need boundaries. We can say boundaries, and then we divide that into two: lower class boundary and then upper class boundary, like that. And then we are going to have, after boundaries, now we have our interval width. Remember, we need it. That's the reason why we've put the boundaries, so that we can get the interval width. Then we are going to put our frequency, and then using interval width and frequency, we get the important guy, and that is going to be our frequency density, right? So we go ahead. Let's put our weight in grams the way we got it. So let me make the tables like this. And then we make another column. And then this one is split right in the middle. And then we cover up this one. Then the next. And then the next. Great job. And then we do for this guy. You don't want him to be slanted. You want him to straight. Okay. Now we do this. Too long. I'm sorry. Get it up to here. Up to here. Great. Then for this guy, up to here as well. And then here we have it like that. So yeah, we are done. Now we're going to put our things. We have 21 to 50, 51 to 60, 61 to 80, 81 to 110, and then 111 to 150. Now we need to put our boundaries. So this is why we've done this as a second example. There's something very important in here, and that is, look at the way we've gotten our intervals now. In the other example, we got our intervals as what we call interval notation, which we had inequality sign. And we said when we have inequality signs, that is actually those are actually the intervals that you have right there. So if I say 3 less than or equal to t, which is less than 6, 3 and 6 are my intervals, because I've gotten it in what we call interval notation. It's already in interval notation, so they already are your intervals. But now, if you get a hyphen, this dash, these are not intervals. They are endpoints. They are not telling you the intervals, okay? If we say we are going 21 to 50, that's not the interval. The interval is actually going to be determined then by what we measure to the nearest. So here we measure to the nearest gram, and that is 1 gram, right? We divide it by 2 first, we will get 0.5. So now to convert this to intervals, we now need to go to the lower bound, subtract 0.5, go to the upper bound, and add 1.5. Then we have our boundaries. So 21 minus 0.5 becomes 20.5 as the lower bound. It becomes, so we have 20.5 as our lower bound now, and our upper bound becomes 50 plus 0.5 becomes 50.5. You keep doing for the rest. Now 50.5 is obviously going to be the lower bound for the next. We don't have to say 51 minus 0.5. We already know that the upper bound for the other guy would be the lower bound for the next. So here, for upper bound, we would say 60 plus 0.5, we will get 60.5. Do we need to calculate lower bound in the next step? No, we just copy and paste 60.5 because it was the upper bound for the previous step. Now, upper bound, we got to calculate. 80 plus 0.5, we get 80.5. Do we need to know the lower bound for the next one? No, we know it is 80.5. And then this one, we say 110 plus 0.5, we'll get 110.5. Then for here, we say, do we need to calculate? No, it's 110.5. Then for this one, it will be 150.5. Here are our boundaries. Now we can go ahead and get the interval width. Great, that's how you must do it. Be careful when you get it. When they will give you these hyphens, they are giving you the endpoints. 50 is the endpoint, 21 is the endpoint, but they are not necessarily the boundaries. We would then have to convert to boundaries. So they'll tell you what it is to the nearest. Okay, we'll see with more examples. Now here we go. We can now get the interval width for each and every one of these cases. Let's go ahead and let's try to find. So what would we do? Well, we are going to try and find our width. So it's a 50.5 minus 20.5, isn't it? Okay, great. So we'd say 50.5 minus 20.5. What would we get in this case? We'll get 30. That's obvious. So ours would be 30. Here's 60.5 minus 50.5. You get 10. 80.5 minus 20 minus 60. You get 20. And then 10.5 minus 80.5. What would you get? 30. And then now 150.5 minus 110.5, you would get 40. So 40 for this guy, 30 for him, and then 20 for him, 10, then 30. So now we can go ahead and get and put our frequencies. We know them. This one was 18. We're just copying from the other table. 30, 22, 34, and 10. Now we can go ahead and get frequency density to be just frequency over class width. 18 over 30, 30 over 10, 22 over 20, frequency over interval width. Remember, that is the frequency density. Density, how much frequency, over the space you have, which is interval width. Great. So we go ahead and put 22, then we have 34 over 30, then we have 10 over 40. Now we can start to put our things and get our solutions, right? Now it becomes easy for us. Okay, so this one, 18 over 30, you'd get 0.6. 30 over 10, you'd get 3. 22 over 30, over 20, you get 1.1. 34 over 30, you